Hello, Hera. Can you help me with something? We've been talking a lot about the chance of, for example, finding heavy dogs at the Animal Daycare Center, ADCC, and the chance of finding a certain number of treats in a better treats bag. And I presume there are more situations when we want to know the chance of something. So, what is it that helps us figure all this out?
Hans, you have really hit on one of the most important concepts of statistics. Many years ago, someone noticed that if we draw a sample from a population, like 100 dogs from a population of all the dogs that visit ADCC, and look at characteristics from the sample, like the dog's weights, heights, and so on, a pattern will emerge. This pattern can be illustrated with a bell-shaped graph called the Gaussian distribution, or the normal distribution. Distribution is a statistical concept that describes a collection of 100% of the variables or observations, like weight or height, usually arranged in order from smallest to largest on the horizontal axis, also called the x-axis. On the vertical axis, also called the y-axis, we note how often or the frequency a particular variable occurs, such as the height or the weight. This distribution is completely symmetrical, so 50% of the area is to the left of the mean and 50% of the area is to the right of the mean. The area of this curve goes on forever. It never touches the x-axis. Most of the variables will cluster around the average, or mean, score, while the least frequently occurring data will be at the tails of the curve. No pun intended. For example, if we draw a sample of dogs from ADCC, we find that most of the dogs' weights immediately surround the average of 50 pounds. But there will be a few dogs that weigh as little as 10 pounds and a few that weigh over 90 pounds that can be found in the tails of the curve.
That is amazing, but how does this help my knowing the chance, probability, of, for example, finding dogs that weigh less than 60 pounds at ADCC?
When I weigh a sample of dogs visiting the ADCC, I can calculate their mean weight, and I can also compute the dispersion, or the spread of the data. I do this by averaging how far each observed weight is from the mean. The number I get is called the standard deviation. In statistical jargon, we can say that the standard deviation of the sample distribution is the measure of the mean random variation we would expect from samples of equal size drawn from the same population.
Wow, that's powerful. By the way, why is it called standard?
Because we are measuring the variability of the data to an agreed upon value, the mean. We are standardizing the data, comparing data on an agreed upon scale.
So, I now know that the observed sample has a mean and data points that can be computed as an average distance from the mean. Where is the probability?
Here is an amazing thing to know about the normal distribution. Always, 68.26% of all the observed data can be found in the area between one standard deviation below and one standard deviation above the mean. 95.44% of all the observed data can be found in the area between two standard deviations below and two standard deviations above the mean, and so on. So, if you can calculate how many standard deviations a particular weight is from the mean, you can compute the area above and below this particular standard deviation. The percentage of this area is the probability. Hans, I know you don't like math and formulas, but let me give you an example. Let's say that the mean weight of the dogs in my sample is 50 pounds, and one standard deviation is 10 pounds. If you look here, you can appreciate that 34.13% of all dogs can be found between the mean and one standard deviation above the mean. You also know that 50% of all dogs weigh less than the mean, 50 pounds. Thus, 84.13%, 50% plus 34.13% of all dogs weigh less than 60 pounds. In other words, there is an 84.13% chance to find dogs at the ADCC that weigh 60 pounds or less.
So, if there is approximately an 84% chance of finding dogs below 60 pounds, there is approximately a 16% chance that there will be dogs at ADCC weighing more than 60 pounds?
You got it, Hans.
Thank you, Hera.